Hi, I'm Nitin. I'm part of Team 64. I'm here to present our project on network intrusion detection system using machine learning. Our aim was to build a machine learning model which could be incorporated into a intrusion detection system so that the incoming network packets can be classified as part of an attack or not. The dataset we used is publicly available on Kaggle. I'll go through the data description now. And here is the statistics for the different application layer protocols. So these are the different types of attacks we are trying to classify. We have 8 broad categories: DDoS, brute force spoofing, DOS, recon, web-based, and melee. And then within each of those broad categories, we have several other types of attacks. Totally, we have around 33 attacks. Most of the entries in our dataset are part of a DOS attack, which causes class imbalancing problems, which we'll discuss later and how we resolved it. So these are the input parameters. So the main ones we have to be looking at here are from number 9 to 15, which are the TCP flags. And we can see at number 42, we have the number of packets in the flow. Denial of service attacks will have a fairly huge number of network packets. This is how the data looks, and these are the labels. So you can see that the labels are strings here. Then we convert them into integers and then to a one-hot encoding representation so that it can be um, passed into the model for training. This is our baseline results. This is from the paper, and we can see that denial of service attacks are fairly easy to classify because of their nature, and the other ones, spoofing, web, and recon, we have a lot of false positives here, which is pretty acceptable because they're pretty hard to classify from the perspective of a network intrusion detection system. So we used multiple architectures and different types of classification. So first we are detecting if the packet was part of an attack or not, and then we are detecting which type of an attack, which attack group the attack was part of, and finally the individual attack itself. We are normalizing the data using the standard scaler available from scikit-learn, and we are inserting zeros wherever we find nans. And as we saw before, our data set is imbalanced. A few attack classes are a very low in number, so we're using random oversampler and smart techniques to increase their count so that our class is balanced and it can help our model learn better. So for the weights, we are using the formula here. We initially used the standard formula, which is the total number of occurrences divided by the number of occurrences for each class, which did not work out well for us, so we went with this. If you'll see the results of the random forest classifier now, this is and these are the accuracy results. We can see here that we have a lot of ones in the middle here, which are part of DAS or Mirai, which are a bit easier to classify. And then to the bottom here, these are the web attacks, which are pretty difficult to identify. Next, we are using logistic regression to classify if the packets were part of an attack or not. So it's a binary classification, and this was fairly simple model, and we got really good accuracy scores here. We have 94% on the validation set. This is the confusion matrix. So next, we are trying to uh, use logistic regression to classify the data into different attack groups, and we got about 82% accuracy, which is fairly good, but the confusion matrix is not as impressive as before. And finally, we have the multi-layer perceptron. We are using model as described here. We have around 200,000 parameters to be trained. It's very complex, and accuracy scores are not as good because we are trying to classify 34 different types of classes. And as I've discussed before, the denial of service attacks are a bit more easier to identify, and the web-based attacks are a bit difficult. And we're still working on distinguishing between. I get extracting the features properly so that we can improve the accuracy while classifying the web-based attacks. Conclusion: we have successfully developed 3 different models and for four different types of classifications.